Okay, please take your seats so we can continue with the next session. All right, so there has been a bit of rescheduling of the talks because Jelena Mitrovic is supposed to be the talker right now, but because of some delay in the operation, she couldn't manage. So I would like to present the one who will be in charge of this session instead of her. I would say the true representative of successful women in the field of engineering and computer sciences. She will be telling us about natural language processing in Python. So I would like to for you to join me in welcoming Ranka Stanković. Give it up.
Ladies and gentlemen, dear colleagues, I'm very honored to be here today and to bring you some introductory topics related to one field that I work for several years now. It's natural language processing, but here we'll talk just about its application using Python. Generally for NLP, as we call it as an acronym. We use also some other tools, especially for Serbian language. But Python is a tool that brings more and more attention, so we are also moving some of our tools into this environment. I mean, not particularly in Jupyter, as you can see here, but for our teaching, usually, especially for introductory course, we are using Jupyter Notebook. This talk will be generally based on a book which is open and you can freely use in your research. And it's called Natural Language Processing with Python, Analyzing Text with the Natural Language Toolkit. And here you can see a structure of the book. Generally, some introductory topics in the related to language processing are also done in this book, so you don't need some special background in NLP before reading this book and using code within this book. So for some large NLP task, you would need, of course, some other books, but for some basic thing, you can start with this book. So, for running examples in which I will present here today, you will need a few libraries. You see here NumPy, Matplotlib, and of course NLTK, which can be easily installed on your system. Here you can see how you can import and download automatically. When you download, you will be asked, I will not test it now, but you got a screen and you will be asked which resources you would like to do it. And usually you can take some of corpora, some of text collection, or some lexical resources. I would like to ask you if any one of you have done text processing at the moment. Okay, that's good. Corpora, for the people that are not familiar with, are generally large textual collections, which can be raw text, but usually for some advanced processing, they are annotated with some additional information. Generally, we have some metadata annotated to know from which author, from which field, from which genre, from which year those texts are. And also words and parts of those texts are annotated with some grammatical or syntactic feature. One important tag or annotation is part of speech, from which we generally start. During this presentation, I will show you some way how to do that. So in this book, with this toolkit, you can download several different corpora which are freely available, and among them are also some Serbian texts, but here I will present example on English. For example, when you download your corpus, one that you would like to do, generally each text in that corpus is assigned to a variable, and here you can see variable text 1, text 2, text 3, etc., and each of them is one text. And if you check to see information related to one of these variables, you can retrieve basic information related to a text that is behind that variable. Here you can see the title of first and third text in it. How we can see the content of that text collection or one particular text? Usually we do some concordances. Concordance is a list of words given in its context. Linguists usually, when they analyze one topic or one author, they make a concordance of a whole book, of whole novel. But here we can search, for example, for one word. And if we search, for example, for word monstrous, in one book, we retrieve a list of keywords in context. So we can see the left and right context of that particular word. And what is special about concordances? You can compare how one particular word is used by one or by other author. First time when you run concordance, it's a bit slow because in background index of concordances is built, but later on it goes generally smoothly. Of course, it depends on the size of your corpus. If you have a very, very large corpus, you will need some additional tools. It will not generally run on a desktop computer. So we will see here how this same word, monstrous, is used in different books. We can see that same word in one book can be used in positive, in other in negative sense. So the context is that gives a sense to a particular word. We cannot look for one word without its context. And here we can use similar as one function that gives us words that are similar to the selected words, but similar only based on that text. So here we are using text 1 to see which words are similar to this selected words monstrous. And we see here true, contemplative, Christian, abandoned, etc. And then we can use second text and see what second text will gives us for that word, which words are similar. And we see very so, heartily, as good, great. So we can see now positive context. We see here that one same word in one text is used in negative and in other in positive context. That's why we generally don't use in NLP small text, and we don't generalize our opinion on one particular text. It's generally used on thousands and thousands of novels. And for example, contemporary corpus of Serbian language have about 5,000 different novels. It's about 120 million words. And here we will see how we further analyze context. We can now see how, for example, in this text 2, common context is deduced from these two words. For example, we have that very, we saw here that is similar. We now try to find why it is similar, and we try to find common context for these two words. And it appears that a pretty, am glad, a lucky, is pretty, be glad are common context for these two words. As we all know, a picture is worth 1,000 words, so visualization in corpus analysis is also very important. And if we want to see a quick look on occurrences of particular words, we can use a very nice function, which is called a dispersion plot. And you can select one text and ask for dispersion plot for list of words, list of tokens, however you want to call them. And here you can see for citizens, democracy, freedom, duties, and America. Corpus 4, text 4 is actually a text with inauguration speeches of presidents of the United States. So if we, from the beginning, concatenate all inauguration speeches, we got this list of 140,000 words, and we can see how many times particular words appear. And we see that citizens are used all the time. So we have some citizens in all inauguration speeches. But democracy is something that was not present at the beginning. Then we have some democracy, then a long period without democracy, and then later on again. Freedom is also something that is not so frequent at the beginning, but later it's more frequent. Duties at the beginning are more frequent than later, and America is very frequent lately. So I suppose that this code will be shared, so you can search for some of your interests, some words that are interesting for you. General usage, one of the usages of corpus is also to help lexicographers to build dictionaries, lexicons of various types. So they are analyzing all occurrences of words. And during that, we would like to first to see which list of words is in a particular text. We want to see how frequent some of them are, which are together more frequently than the other, and so on. So here you can see one example of such calculation. If we just say length of text, we count just words, number of words, actually tokens. Difference between tokens and words in different systems are interpunction, point, sentence delimiters, etc. Numbers are sometimes called just tokens, not words. But for these simple tasks, generally, a difference between tokens and words are not so important. If we use something like this, length of a set of text, we know that set will gives us only different, and then it means that this particular text have 2,789 different words. We can also print, sort, usual things that we do with ordinary lists. One of things that are also important in text analysis is lexical diversity, to see how diverse is occurrence of different words. And here you can see that it is calculated by dividing number of different tokens, different words, with total number of words. And here you can see rather small lexical diversity, 0.06. If we have lexical diversity 1, it means that we don't have same words repeated twice in that set. If we want to calculate frequency of occurrence of particular words, we can just type text for ask for that text which we are now analyzing, and then count particular token or word. And that absolute frequency is, generally speaking, not so useful. Why? Because you never have the same length of text. And in order to compare frequency in different size text, you have to somehow make relative frequency out of that absolute frequency. And the easiest way is to divide absolute frequency with total length. And so you have something that you can compare between different texts. So in NLP, you usually work with relative frequency, not with absolute frequency. As you all know, some things that are performed several times, one by one, we generally make some functions that helps us build a cleaner code. And here you can see an example of small function that we call lexical diversity, which will automatically calculate this lexical diversity and percentage. And after generating this function, we can call them whenever we want in our code. Here you can see some information related to genre, relation between number of total tokens, types. Types are generally a term that is used for different tokens. So it means that in these 82,345 tokens in the Skill and Hobbies book, we have so many types. And generally, we are analyzing diversity of different type of books or genres or novels or newspapers. And it is not out of surprise that novels have higher lexical diversity than some other, for example, in Bible, we don't have so big lexical diversity, also in everyday newspapers and so on. Okay, so those examples were related to the text as a whole. Now we have some examples how we deal with some smaller chunks of text. A smaller chunk of text is, of course, a sentence, and you have here one sentence. So list of tokens which call me Ishmael, and full stop here. So this sentence is actually a list of 4 tokens, and if we calculate lexical diversity, it is 1 because there is no token that is occurred twice. We can concatenate sentences. You see here usual concatenation of list. But from our corpus, we can also concatenate sentences like this. So all sentences in our corpus, in our texts, are could be retrieved like this. We can also append some text to existing sentences. All these sentences and texts are indexed. We can access to the content either by these variables or using some indexes. And you can see here some example of this call. Also, you can retrieve not only one, you can retrieve several tokens out of this list. And you can also add or delete or change the order of content. Here you have some examples how to just extract some words from those sentences. You can also extract information which are not only text. If your text is annotated with some additional metadata, I will now skip some text. You can also do some statistic related to counting not word by word, but for a set of words. How do we do that? For example, we want to calculate frequency of all words in one text. And there is one very nice function which is called frequency distribution. And this frequency distribution calculates occurrences of all words in your text. And you can see here, for example, 50 most common, so means most frequent tokens in that text. It is comma, the, point, of, and. So generally, most frequent tokens are punctuation marks and so-called functional words. And generally, they don't tell us much about a text. So most frequent words are not those words that brings us some meaning. So there are some other tools how to retrieve the keywords which are related to the text. Here you can see a plot which shows frequencies of these most frequent words. And you can see that large parts of a corpus are those most frequent words. So we don't want always those frequent words. We want some which are special for that particular topic. And there is another function which is called hapax, which retrieves words which occur only once in a particular text. But if we want, for example, we see that this only frequency don't help us much, so we want some additional filtering to apply to our text. And for example, if we want to select only large words which have more than 15 characters, we can do something like this. We always apply set function for this type to retrieve only different tokens, and then with this small loop we select only those words which are larger than 15 characters, and here you can see few examples. If we want to combine, for example, we want words which are with length larger than 7 and which are frequent, which occurs at least 7 times, we can do something like this. Other important thing in language processing are collocations. Collocations are occurrences of more than one words. So we try to find words which co-occur with other words more frequently than it is usual. One example is, for example, red wine or white wine, or those two words gives us one phrase, one multi-word units, as we say, or multi-word expression. So these are similar things. So in Python, we also have some tools to find out those collocates. Generally, collocates can be of 2 words, it can be 3, so we call it bigrams, trigrams. General term is n-grams. Here you can see one example how we to retrieve bigrams of one simple list. More is said than done. So system finds out all bigrams, so occurrences of words one by one. And when we apply this function to find collocates on a larger text, generally it gives us some meaningful results. And here you can see that United States fellow citizen 4 years ago, etc. So some expressions are given here. Later, we can use that for several other things. So we can make distribution, for example, of all those collocates. But we can substitute this retrieved result with something else. For example, with length. We want to see which length is most usual. Is words with 4 characters or 5 or 3 for specific text is most common. So we can substitute our words with length and then also apply same frequency distribution function and see the results. And here we can see frequency distributions for length of words. And which is most frequent? So here, this shows that words with 3 characters in this particular text are most frequent. We can apply most common function, and here we have a sorted list of most common. So the first is 3, then 1, 4, 2, etc., etc. Function, usual function maximum, will give us what we saw by our eyes, that it is 3, and here you can see some other function related to that. Also, of course, we can use some conditionals related to text to apply on textual list as in other things. I will not go to in detail, but some specific function are that we can apply some function like starts with or ends with, is lower, is upper, is alphanumeric, is digit, is title means is it first uppercase, and so on. So we can combine all these functions with usual programming style. I will skip some. This is nothing special for, it's not related to text, and now comes something that is related to NLP. Part of speech tagging is after tokenization. There is a pipeline when we analyze text. First thing is to make a tokenization of a text, and the next thing is part of speech tagging. What is that? Each word is assigned part of speech. For example, nouns, verbs, adjectives, and so on. But not only that, we can also assign some additional grammatical information related to particular words. And here we can see that each word is annotated with some tags. And for example, this is noun, this is adverb, this is adjective, and so on. And generally, all corpus are, or professional corpus, linguistic corpus, are annotated at least with part of speech tags. And several functions are now dedicated to exploration of this specific feature. Way of tagging and way of annotating just a second, is something that is related to a particular corpus tool that is used. Sometimes this annotation is done in XML, sometimes it is like here in simple text with some usage of some marks. So here each word, each token at the end is separated by slash, and then part of speech tag is assigned. So this is the simplest way of annotating text, and generally it should be something much more complex. Here you can, with this NLTK corpus Brown tagged words, you can retrieve actually dictionary of all words with annotated tags and start with analyzing. Here, generally Brown corpus is one of the oldest corpus for English, and here you can. It's freely available. It's included in NLTK package. Here you can see all tags, and in documentation you can see each tag is related to some grammatical feature. It's long list, and it is not so standard. Now there are a lot of effort in community which are related to standardization of those tags, and there is something that is called universal dependencies, which is now not still standard, but something that everybody try to re-annotate its resources. Here you can see, for example, how you can retrieve most common verbs in news text. There is one corpus which is called Tree Bank, where some additional information are retrieved, and with this feature you can find out which are verbs that are most commonly used. Also, you can see some, we call it syntactic patterns. For example, if you are working on some terminological dictionary, on some terminological glossary, it is well-known fact that in lots of languages, pattern, adjective, noun is most common, and you will start with retrieving bigrams which have adjective, noun, pattern, and add filter also most frequent occurrences, and that will be a good start for your dictionary production. If you want, for example, see a pattern which is verb to verb, you can make a small code like this and retrieve examples like combined to achieve, continue to place, serve to protect. And what is good with corpus analysis, we automatically can attach a context to this particular, you can automatically attach a context with this particular pattern. You can also define some dictionary with attached to each term its part of speech, and then in further processing use that dictionary and combine text and that dictionary. So you somehow produced some derived resource quickly. In Serbia, dictionaries are still produced by very, very traditional way. While in other communities, it is done generally automatically. Also, we have prepared one example for solving classification tasks. For example, you can use general lists. For example, here we have one list with male names and the other with female names. And then we can try to find out for a set of new names that we don't know is it male or female, to see how can we classify those unknown, unclassified names. So usual thing is that we make some features, and here feature will be, for example, ending of words. In Serbia, generally, female names are finishing with A, but also in English, there are some rules similar that can gives us a clue about ending. And here is prepared one classifier, which, according to this data, can classify new names, is it male or female. And here one option is prepared with classification on one last letter, and the other is prepared with, and it gives us accuracy of 0.748. But if we take two letters, then we have better precision, and it gives us, I will scroll down, some a little bit higher accuracy than this one. The idea is generally to substitute some data with a feature and then train and use test sets, and as in other machine learning tasks. I tried to keep times that as we... Okay?
Okay, so we have a bit of like 8 minutes more. We received a lot of questions on Slido. I don't think that we'll have more time for Ranka to answer all the questions here. You can always catch her in the hall, in the lounge, whatever you need. I suppose that you can now answer to some of those.
Yeah.
They're on the screens, and you can also see them here. They are set by the most likes from the audience and everything. So whoever doesn't receive a question right now, you can always check with her in front of the hall for additional information. So.
Okay, I can quickly answer a few. How do you know that the context in which the word was used in positive or negative? Is there a metric? Yes. We can use several things. One most commonly used things is to use some lexicon which already have some information about positive or negative mark on a word. One such resource is WordNet, and its addition SentiWordNet, where for each word you have some counting, and you count whole context, and it's counting of those words in context, you know, is it positive or negative. Of course, you are not always 100% sure, but if context is larger, then the precision is higher. Is it be possible to deduce sarcasm? Yes, there are some in our bibliography. You can see one paper which is related to sarcasm as well. So for those more interested, we can talk about that. But precision for sarcasm is not so high. It's about 60–70%, I think. Fake news is one very, very hot topic. And a lot of research is now going on with fake news, but I think there is still no final answer. Generally, sentiment analysis, we don't do that in NLTK. We are using some other tools and combination of tools. First of all, Unitex is, all our resources are in Unitex. I don't know, what is your, I don't have experience with Spacey. Related to synonyms, for example, WordNet is one of the resources when concepts are explained as a set of synonyms, and with special lexical resources you can handle them. How would you, is it mentioned Compora for Serbian language freely available on the internet? It is available freely for search and for research, but it is not downloadable. One of the obvious reasons is that texts in corpus are copyrighted by other authors, and Faculty of Mathematics received just right for concordancing those texts, so they cannot be freely available for download. But at the moment, during one cost action, now we are building one with old books, corpus that will be freely available. It will be 100 novels from 19th century and 20th century, beginning of 20th century, which are not copyrighted, and they are now, it could be used for any kind of research, and I can just call to...
Thank you, Ranka. Can we all thank Ranka with a great applause for this wonderful presentation?
My name is Ranka Stanković. I come from the University of Belgrade. I'm very first time here, and I'm very glad to be here in such a marvelously organized conference. And I hope that it will be traditionally held in Belgrade with a dear colleague of mine who should have been here today, Jelena Mitrović. I prepared a presentation related to natural language processing, NLTK in Python.